Good afternoon, and thank you all for joining the second of the Merrick & Company's Biosafety and Biosecurity webinar series. Today's webinar, Biosecurity in Animal Laboratories, is going to be presented by Dr. Bob Hawley, Dr. Lauren Richardson, and Dr. Ryan Burnett. Before I introduce our presenters, I want to share a few details about the mechanics of the webinar. First of all participants will be muted. If you have a question, please find the chat box function on your GoToWebinar panel and type your question. There will be opportunities throughout the webinar where we'll be addressing the questions, but if time does run short, any of the unanswered questions will be responded to in writing via email after the webinar concludes today. A link to today's recording will also be provided on the Merrick website, and we'll be sending out instructions to access the link after the webinar concludes. As an interactive webinar, today's session will feature polls and discussion questions that you will all have the opportunity to respond to. When a poll comes up during the webinar, we'll direct your attention to the questions, and you can respond by clicking from the multiple choice answers. Your answers will be anonymous, and tallied responses will be shared for all attendees to see. As a test, we're going to try a quick, simple one. So you'll see the poll, are you enjoying the weather in your area today? And you should be able to respond to the poll. All right, Ryan, have you been able to close out the poll? There we go. So you'll see the poll results up on the screen after everyone's provided an answer. For the discussion questions, feel free to enter your responses and thoughts in the text box in the chat function, and we will review the questions and the answers as they come up to us. If you have any questions or technical difficulties during the presentation, please use the chat feature in your GoToWebinar control panel. So now to introduce the presenters that we have today. Dr. Bob Hawley is one of the most recognized and respected authorities in biological safety, with decades of experience providing expertise to countless clients, including federal agencies and domestic and foreign governments, spanning issues of biological safety, public health, and microbiological research. He has held numerous positions, such as a safety and occupational health specialist and chief at the Safety and Radiation Protection Division at the U.S. Army Medical Research Institute of Infectious Diseases, and served as the Command Biological Safety Officer for the U.S. Army Medical Research and Material Command. In addition, Dr. Hawley has served as a consultant to international organizations and federal agencies. He's also a member of the United Nations Special Commission Inspection Team in Baghdad, Iraq, and the Defense Science Board Task Force on Defense Against Terrorist Use of Biological Weapons to the Office of the Secretary of Defense. Dr. Hawley has a PhD in microbiology from the College of Medicine and Dentistry of New Jersey, a Master of Science in Microbiology from Catholic University of America, and a bachelor's degree in biology from Pennsylvania Military College. Dr. Hawley is recognized as both a registered biosafety professional and a certified biological safety professional, and has served as the president of ABSA from 2006 to 2007. Previously, he was also the president of the Chesapeake affiliate of ABSA. Dr. Richardson has a background in veterinary medicine and public health, with experience in large and small animal clinical medicine, food safety, and defense, and infectious disease. Last year, Dr. Richardson joined Merrick & Company's Life Sciences unit as the Associate Director of Biosafety and Biosecurity Programs. Before joining Merrick, she provided technical subject matter expertise and project management for international projects focused on food safety, laboratory, and health systems capacity building. Prior to this work, she worked in equine and mixed large animal private practice in Virginia and North Carolina. Dr. Richardson also serves as a veterinarian in the U.S. Army Reserve. She holds a Doctor of Veterinary Medicine from the Virginia-Maryland Regional College of Veterinary Medicine and a Bachelor of Science in Biology from the University of Virginia. Dr. Burnett is the Director of Biosafety and Biosecurity Programs at Merrick in the Life Sciences Business Unit. He has consulted on the biorisk management programs and biocontainment laboratories at academic, government, and industrial clients in the U.S. and over 30 countries. He's currently the program manager supporting the multifaceted operational planning of the National Bio and Agro-Defense Facility as a contractor to the U.S. Department of Homeland Security. So those are our three presenters for today, and with that, I will turn it over to Dr. Lauren Richardson to begin the presentation.
Thank you, Kelsey. Great to talk with everyone today. Thank you so much for joining us. So I'll just briefly go over the objectives for today's webinar. We'll do a brief review of biosafety and biosecurity concepts. This is mainly a review of last time's webinar with a little bit of definitions thrown in. We'll discuss the impacts of animals as assets, threats, and vulnerabilities impacting laboratory biosecurity programs. We'll describe animal screening and management for biosecurity in the laboratory. And we'll discuss personnel screening, training, and integration to ensure biosecurity in an animal laboratory. So as part of our first section, we'll be doing a brief review of biosafety, biosecurity, and threat management. So biological safety, or biosafety, is the discipline addressing safe handling and containment of infectious microorganisms and hazardous biological materials. I think everybody online probably is pretty familiar with biosafety. The proper mix of the three elements of laboratory practices and techniques, safety equipment, and facility design is assessed by the needs and the specific hazards of the facility. Biosecurity is the risk or threat-based institutional and personnel systems and practices put in place to prevent unauthorized access, loss, theft, misuse, diversion, or release of valuable biological materials, pathogens, and toxins, and information, expertise, equipment, technology, and intellectual property that have the potential to cause harm to the health of humans, plants, or animals, or to public safety or national security. Threat management is the implementation of control measures to minimize, mitigate, and manage threats and hazards, and biosecurity is the implementation of these control measures necessary to minimize the threats and safeguard biological agents or valuable biological material. Biosafety and biosecurity programs share common concepts. Both are based on risk assessment and management methodology, personnel expertise and responsibility, control and accountability for research materials, including microorganisms and culture stocks, and in this case, laboratory animals, access control elements, material transfer documentation, training, emergency planning, and program management. Biosafety and biosecurity are related, but they are not identical concepts. Biosafety programs reduce or eliminate the exposure of individuals and the environment to potentially hazardous biological agents. Biosafety is achieved by implementing various degrees of laboratory control and containment through laboratory design and access restrictions, personnel expertise and training, use of containment equipment, and safe methods of managing infectious materials. So the image that you see on your screen is one that is probably familiar to you from the last webinar and potentially from before that. But basically, biosafety involves protecting people from the biological material, and biosecurity involves protecting the material from people. So how do we define biosecurity for this webinar? Often biosecurity with respect to animals refers to protecting the colony from infectious agents. And this is commonly used in industry or farming. But today we're going to focus on the biosecurity of laboratories that work with animals. So here we'll think about how laboratory biosecurity is altered because of the presence of animals. Are the animals a threat to the lab integrity? Are there external threats to the animals? Are animals under research protocols now potentially an asset to protect? How do we protect this asset differently, whether the animal is inoculated or not? And do design and engineering considerations need to be altered to account for animals? So I'll pass over the screen to Bob and look forward to hearing from everyone.
Okay, thank you. Basically, we're going to talk about the fundamentals of risk management and animal laboratories. Next slide, please. And the simplistic definition of risk is that there is a probability that harm or some sort of a disease will occur. while working with these infectious agents. And basically, we have to take the attitude that risk assessment is going to be a subjective process. The containment level may be equivalent to the risk group or raised or lowered as a result of considerations of the risk. Next slide, please. Basically, this slide shows the relationship between risk groups and biosafety levels. And this material is directly from the World Health Organization Laboratory Biosafety Manual. As stated previously, they relate to each other, but they definitely should not be equated. Next slide, please. The poll here is that risk groups are relevant only to biosafety, not biosecurity. Please check your appropriate answer. Is that the right poll, Brian? There we go. Thank you. Do we have an answer or a spectrum of answers regarding risk groups relevant only to biosafety but not biosecurity?
Apologies, it would appear that our poll function is ineffective at the moment. I'm working on that. If folks have a feeling of true or false, they can type that either into the chat box or the question box. My apologies. Based on what I'm seeing coming in, it looks like the response is true. Risk groups are relevant only to biosafety, not biosecurity. The answer I'm receiving most is true. Bob, you're welcome to comment and continue, sir.
No, I would have tendency to make a comment that they are probably relevant to both, based upon the agents you're using and what type of security concerns you have. I think you have to talk about the facilities and then make a decision whether or not there's some sort of relevance to the risk groups regarding biosafety and biosecurity. So I think there's a relationship, and hopefully we'll see this a little further. And then the next slide, please. The risk. Are you going to talk about the chain of infection, or are we going to continue with the risk groups? The chain
yeah.
The chain of infection here shows initially, based upon your risk assessment, the reservoir of the pathogen and how it can eventually lead down to illness. And we have the next slide, the next advance, please. That we can minimize the portal of escape of this pathogen through proper work practices. Next slide, please. And use of engineering controls, biological safety cabinets, administrative controls, protective clothing and equipment, and also the geographic implications and the climatic or any seasonal separation. Next slide, please. We also consider the route of entry infection of the infectious dose, the susceptible host, and how we can minimize that. In addition to what Lauren said initially about laboratory principles, practices, facilities, and equipment, another control could be medical intervention or medical countermeasure through immunization. I have to stress that immunization is an adjunct of safety and does not make you immortal. Just because you're immunized to an agent does not mean that you're totally protected. And we can see that in human cases, that even though people have some degree of immunity, they still may exhibit signs of the infection. Following the susceptible host with the infectious dose, there's a period of incubation, and following that, we can see manifestation of symptoms. And this is usually documented through surveillance, either syndromic surveillance or seeking medical attention. Next slide, please. What type of screening is used for animals before we actually use them in laboratory research? We can screen for various agents, specific agents, and there are a variety of methods. Specifically, if we're dealing with mice, we might do monoclonal antibody production testing in order to show that they're free of any endogenous or exogenous agents. Also, we can do TB testing if we're working with non-human primates. We can also do testing for herpes if we're using non-human primates. What about some of these methods that we'll be using to screen the animals? Microbiome testing is really signifies the ecological community of commensal, symbiotic, and pathogenic microorganisms. And the microbiota of an animal has an enormous impact on the phenotype of the animal, especially or other animal models. And the impact of this microbiota on host physiology is readily observed when comparing conventional to germ-free mice. And this is a topic of discussion that you can get additional information from a lot of publications. Other methods for screening is the next generation sequencing. And we know the rapid advances in technology that we have seen over the years. In principle, the concept behind this technology is similar to capillary electrophoresis sequencing that we used years ago that was pretty slow. And basically, what this procedure does is allow you to look at thousands of animals and see the differences among them to discover critical genes that can cause a variety of diseases. Now, let me go back and mention the MAP testing. This is a mouse antibody production, rather than what I said before, monoclonal antibody production. But this mouse antibody production used to test for transplantable tumors, hybridomas, cell lines, and other biological materials for contaminating infectious agents of different types, showing that your animal is free from any, as I said before, endogenous or perhaps exogenous infection. What kind of references can you use for this? Especially when you're working with animals in the laboratory. The American Biological Safety Association has a number of publications called the Anthology of Biosafety. And these publications can readily be reached at the www.apsa.org. There are a number of publications, and the specific one that I would like to mention is that dealing with animal biosafety. And this has a wealth of information of course, working with laboratories, working with laboratory animals. The American Veterinary Medical Association offers many publications, and again, you can just go to the website. The Department of Health and Human Services has a publication, Public Health Service Policy on the Humane Care and Use of Animals, and also laboratory animal medicine textbooks. So there are a lot of references out there that, depending upon the risk that you're dealing with, will allow you to address what type of testing that you should probably consider for your animals before you actually subject them to any research protocols. Next slide, please. The animal screening, depending on the type of animals, most of the animals that we get nowadays are purpose bred, so they should be relatively free of any diseases. We also have to think whether they be invertebrates or vertebrates, specifically rodents, non-human primates, aquatic animals. There are a lot of research being done now on zebrafish, and also we have to consider the caged versus loose-housed animals and also husbandry considerations. Next slide, please. The United States Army Safety Center developed a risk management process that I'll mention in a moment. But basically, risk is the probability of something happening that probably shouldn't as a result of a potential exposure to a microbial agent or biological toxin. Next advance, please. And that combination, combined with communication, will hopefully provide you with effective risk management. Communication is a very, very important part of risk assessment and training. Next slide, please. Now, the process developed by the Army is based upon identification of the hazard, assessing the hazard, developing controls, making a risk decision, implementing these controls, and supervising and evaluating. What does that mean, supervising and evaluating? Well, that basically means that you continuously will evaluate the controls that you have implemented. Sometimes there is an initial reaction to suggest that wearing double gloves during a specific procedure. But then we should go back and evaluate that situation, whether or not the risk dictates we should wear double gloves, or the fact that we will have more of a risk by losing tactile response because we're wearing double gloves. Next slide, please. There is a matrix provided based upon risk and threat. The 4 categories, A through D, the most severe category being A, that is a catastrophic event could happen. If the frequency is quite high, it's a very dangerous situation. While going to the other extreme, if a frequency of an incident is rather improbable and it's a negligible consequence, it would be in category D. Next slide, please. Are laboratory animals a threat? I think so. They're very unpredictable, depending upon the animal species. Large animals are a little difficult to handle, damage the equipment, and the number of animals. Accounting for these animals in large numbers adds complexity to your program if you have a large experiment. Mobility, access control. Next slide, please. Animals of vulnerability, behavior. Again, we have to account for the behavior of animals, special conditions for comfort and treatment. And this makes us want to rethink how we should design our biosecurity program. Large numbers. I like the threat of unaccounted for animals, like an unescaped mouse. We have to think about the extra burden these numbers can have on our security program. And are they a target? Mobility. Animals are an asset requiring protection from threats, so mobile assets may require a different approach to mitigate any vulnerabilities. Next slide, please. How about public perception? What about the animal that escaped its cage at the University of Pittsburgh? And the baboons escaping from the Texas Research Facility? Next slide, please. This is a typical scenario. Researchers are working with a onovirus in rats, transmitted by aerosol, and it's zoonotic, causes moderate to severe respiratory disease in humans. There's limited therapeutic interventions. What do you think the appropriate risk group in the BSL, the biosafety level? What do you think they are? Give you a moment to respond to that poll box. All right, responses coming in, Ryan?
No, I'm pretty sure I screwed this one up pretty good, actually. Trying to administer. It looks like that was the one that I launched inadvertently previously. And it is now officially closed, unfortunately. But again, folks are welcome to type A, B, C, or D in their question box. I can see that occurring. Our next poll will work, by the way. I'll give that a minute to come in, and then I'll talk about the results.
Okay, what do we have so far, Ryan?
Yeah, what we got so far is the majority of folks are choosing B, risk group 3, biosafety level 3.
All right, let me comment on that and give you my view in this situation. I would have a tendency to think that a virus such as this could be similar to Lassa fever. This Lassa fever is transmissible through to humans. It's a zoonotic disease found in rats. Causes a relatively severe disease. There is limited therapeutic intervention with ribavirin that's available. So I would have a tendency to consider this a risk group 4 and a biosafety level 4 laboratory in order to manipulate this virus. And I welcome any more comments.
Yep, if there are additional comments, questions, type them in. I'm watching now. And if they come in after the fact, that's fine. We're always happy to go back and address them later.
That's
too.
good. I'd like to hear some of the views of the people outside.
Sure. Yeah, then.
You want to continue now? Next slide.
Yeah, as they come in, I'll certainly come back to you guys, but it looks like they're coming in.
Okay.
So this is the opportunity for folks to ask questions about the last section. If we get questions, great. We will keep moving. If you think of questions after the fact, please send those in because we'll be happy to address them at the end of the webinar. Or if we run out of time, then we will be, as Kelsey mentioned earlier, responding to all the attendees in writing with a list of the questions and answers from the panelists today. Looks like we're good to keep moving.
Yes.
All right. Next slide, Lauren. Thank you, ma'am. So, again, thanks for everybody being on today. I know that the importance of going through a lot of the risk group functionality, I think, is, we started out this webinar, just as a recap, we started out this kind of looking at the relationships between biosafety and biosecurity. I think we're all in agreement that when we look at the risk groups, that really is a function of biosafety. But because there is significant overlap and there is a flow to how we go from kind of a threat management perspective throughout the laboratory into a risk management perspective, ultimately, with the goal of from the biosafety perspective, preventing infection of laboratory workers, the community, the public, et cetera, or animals that we don't want to have infected, all the way back through the biosecurity piece of that, when we have to think about, well, what are the potential threats and vulnerabilities that, if not properly mitigated, then we increase the likelihood of some of those bio risks coming to fruition. So I think it's good to have that sort of in the back of our mind, because now we're what we're really focusing on now is what are the challenges that having laboratory animals in our facilities, what does that do? How does that force us to rethink our biosecurity programs? Next slide, please. So trying to think about what the baseline is, and this is just an opinion, and which you guys that know me know I share those frequently. I feel like the past several decades, as biosafety became a field, a recognized scientific discipline that was practiced and applied, augmented, it really caused us to rethink how we design laboratories. And I think about the engineering controls that have become commonplace, either from a regulatory perspective or a best practices perspective. And I think when we make that jump from, say, a standard BSL-2 laboratory to a BSL-3 laboratory, and we see the rigor of the air handling and controls come into play, you really, and of course the use of primary containment devices, you really start to see how biosafety as a scientific discipline really pushed on architects and engineers and laboratory designers to think about how not only do we put the engineering controls in place to augment biosafety, but they also need to that they can't inhibit the operations of the laboratory. So long story short is biosafety really had and continues to have a very big impact on how we design laboratories. So what we haven't seen a whole lot of, or what I don't know that we have seen a whole lot of in recent years, and maybe this will change, and there certainly have been some additions, is the same order of magnitude of laboratory design considerations through not the biosafety lens, but the biosecurity lens. And here, from a biosafety perspective, when we're looking at risk mitigation and biosecurity, we're looking more at the threat and the vulnerability management and mitigation. Really, what is that baseline? I feel like we have a very good baseline for biosafety in terms of facility design, but what about laboratory design from the biosecurity perspective? And in particular, when we start introducing additional and significant variables like animals. So I think a lot of you guys are probably familiar with the USDA Agricultural Research Service 242.1 standard. And this is where I kind of wanted to start to give that very high level baseline of what is the baseline for animal facility physical security. And I don't know that there's anything earth-shattering here that we don't think about in the context of normal laboratory use versus animal laboratory use. I think the symbolic importance, I really like the statement about that when we talk about the visibility of some of the countries. We're highly engaged in a significant national laboratory effort it's a large animal facility. And we know that there's visibility around that, and I think that does cause operational planners to really think about what is the correct security program, both physically and operationally, that's going to protect that asset. From a criticality perspective, what degree is a building housing operations and functions that are critical to national or regional interests of the U.S. Obviously, this is coming out of ARS, federal agency. They are really looking, they 100% solely serve the United States and the public. So they're really looking at the criticality of that. I think we can also draw some relationships back to our own laboratories, even if they're not national security laboratories or national research institutions. What's the criticality of the operations that are occurring there? From a threat management perspective, this really speaks to how you prioritize your assets, whether they are physical assets or intellectual or animal or biological agent, or and naturally your human resources and your human assets as well. Consequence, again, this is a prioritization exercise for those of you that are well versed in the biorisk assessment process. Same holds true in your threat management development process. What are the consequences of the intersection of a threat and a vulnerability that perhaps results in a risk coming forward? So we have to think about, what are those assets? What do we want to protect the most versus what can we afford to lose? The last bullet point that I think that under the physical security section of the 242.1 standard talks about the threats. And I think this is a very traditional description in the context that we're really talking about people. And as I've said on many webinars and sessions in the past, we typically think of threats as persons. So here, we're concerned about criminal or terrorist activities, whether they are bombs, break-ins, different attacks, insider threats. So all of that really falls into the category of people. And of course, that's where we spend most of our time thinking about things through that security lens. As I've discussed in the past, I think biosecurity, from the threat landscape is possibly bigger than people, and needs to include other hazards as well. But I think this is a perfectly fine definition to really help us establish that baseline. The other point that I will make about threats and what we often refer to as the threat landscape is it's constantly changing. The threats that a laboratory faced 10 years ago are likely different than they are today. 10 years ago, we didn't worry so much about a Wi-Fi drone flying over our laboratories and hot jumping into our IT systems. So the result of that, as we know from our biorisk assessment process, same thing on the threat management process, has to be continually updated with the fact that this landscape is evolving and changing. Next slide. So what are the differences in the facility and laboratory layout that affect biosecurity? We've talked a lot about the biosafety, whether they're primary containment, air handling, double door entry in your high containment laboratories. We've really seen some alterations over the years, bringing biosafety to the laboratory design element. Biosecurity, when we look at the rudimentary or the fundamental controls that we put in place in a facilities level, access control is a big one. We have a variety of different access control mechanisms that we use depending on the type of laboratory you work in and, quite honestly, your budget. Everything from key card entry to biometrics. One of the things that we encourage people to think about is, how does that access control reporting work? And is that really integrated with other aspects of your operational program? A good example that we've seen come up several times over the years is key card entry, and that key card is tied back to some type of personnel electronic record. Do they have the appropriate training? In other words, if they've forgotten to take their refresher training and they're 30 days overdue, does their card get them in? Good question. Inventory control, another measure. I think we repeatedly see folks get knocked on this one. I could speak from multiple examples of personal experience that keeping up with all my inventory was not one of my strong suits. And this is something that I think as we get more and more fall under more and more scrutiny about what agents we have and what we're doing with them, this becomes a bigger issue. Lab configuration and workflow, no doubt. This is where, in a design process, I think it's so important to have the researchers, the veterinarians, the animal handlers, the biosafety officers involved in the design process. I would say over the past 10 years, I've seen more and more of that. If you leave it to the architects and the engineers, even good seasoned ones, sometimes those things are going to get missed. We want to make sure that the science and the operations that support the science are well blended with the design approach. If you were like me coming up in the laboratory environment, you know, a laboratory was basically a box with a lot of outlets and pipes and plumbing, and you made do with what you had. It wasn't necessarily a process of designing around what the operation should be. If you have that opportunity, having the right stakeholders is there. Long story short, we obviously know that workflow and laboratory configuration plays a big role in safety. It also plays a big role in security. Visibility is a big issue when we talk about designing laboratories from a security perspective. So we'll talk about that a little bit more. And of course, the biosafety level conditions. It's a little bit squishy to talk about, but the biosafety level really helps us establish the baseline of the engineering controls and practices that are built around the proper risk mitigation for the agents and operations that are occurring in that given space. Ergo, biosafety. At the same time, containment labs, whether most of them are secondary containment, but even those that are primary, like your large animal, when you look at it through the threat management lens or the biosecurity lens, we're also thinking about the fact that it is helping to contain things that we don't want to get out, not just through an accidental release, but perhaps through that threat management piece, and that is intentional release. So all of these things blended together, I think, really help that. Next slide. So, courtesy of our buddy Dave Bressler here, we're looking at an example of a facility layout. And you can see towards the left of your screen, you've got your perimeter entry coming off of probably a public corridor or a less restricted corridor, you know, all the way through into your laboratory entry. And as you walk through that corridor, you can see that there's a central corridor running through the middle of the laboratory with a lot of your specimen in processing, whether you have samples coming in, moving through the research area and into specimen storage for things that have to be saved after the fact. Towards the bottom of your screen, you can see not only the supply storage, reagents, tubes, disposables, and animal housing. Finally, what you've got moving towards the back of the lab, and notice this directionality as we go from left to right, is our ability to pass things out of the laboratory, whether that is through the pass-through box or dunk tank of sorts, or if we are deconning things out of the laboratory through an autoclave that comes out of the laboratory back into a less secure environment after it's been deconned. The proximity of the loading dock, not everybody has a choice on this one, it's certainly recognized, but from a preference standpoint, you want to have your loading dock proximal to where you're going to be getting your stuff in, whether those are basic supplies or whether those are large animals. This is also a point of security feature. We tend to put a lot of these security elements and the access control more on the people side, and that would be on the left side of your screen as people come and go out of the laboratory. In reality, you know, the same thing from the loading dock. What we take in and out of the lab through those other portals, if you will, I think is also pretty important for us to consider. Bob, I didn't know if you had any other comments that you wanted to take folks through on this slide.
Now, just one of the important aspects is that the configuration of a laboratory, and this is just one example of many, that the configuration is really predicated on the risk, what you are doing it with, what kind of animals. Another situation here is you have the animal housing, but you know, where are you going to keep the animal food? You know, bring it into the laboratory every day, or are you going to have keep it in a central storage facility, or have a facility within the laboratory? So this is just an example of how a laboratory may very well be set up. The important thing, and that I want to impress upon everyone, is that whenever you're doing any of this, the first thing you think about is, well, what is the risk? You have to, as Ryan's mentioned previously, when you're designing a facility, what it's going to support, you have to have input from not only the laboratory animal people, the biosafety officer, other security individuals, but also the maybe information technology people, because you're going to generate a lot of data from this laboratory. How are you going to get that data out, especially if it's a containment facility? So thank you, Ryan.
No, good point, good point. And you know, some of the things that we've seen come from, you know, Bob talked a lot about the risk portion of this, designing this from a risk perspective. And that's 100% true. And I think where people start to scratch their heads a little bit is, how do we do that from the threat management perspective as well? And one of the things I like about this layout, even though it's idealistic and somewhat simplistic, is the flow, the directionality of how things go in and out of the laboratory. The other thing is that that central corridor running through there, you know, gives the personnel that have access in and out of this lab good visibility across all of the different areas. And I think things like that sound simple, but they're often overlooked. Understand we've got a bit of a group discussion coming up on the next slide, Lauren. Let's go to the next slide and see what we got here. All right. So this is an opportunity for you guys to put statements or questions into your question box. I'll relay those back to the panelists today. But essentially, of the folks who work in animal facilities that are on the webinar today, what are some differences you note between the image below and your own facilities? Do you see things in here that you like? Do you see things in here that you don't like? You know, what's impractical? What's worked well? This is your opportunity to share with us, you know, a challenge, a concern, or a question. And I'll let that tick away for a few minutes.
Yeah, Ryan, while your folks are submitting comments, let me again mention other individuals that may be involved in the laboratory design process. You may very well involve people in the community. We know of many situations where the community wasn't involved from the initiation of any thoughts about building a laboratory. And as a consequence of that lack of interaction, there were some difficulties in getting the laboratory to an operational status. The other situation here is the laboratory entry. In that laboratory entry box, there probably could be a number of other little small rooms. They could be change rooms. Is your risk that you anticipate, will it help to mitigate that risk by requiring the people to take a shower upon exit of the laboratory? So this is another thing you have to think about. Now, how about the autoclave? Are you going to have a single autoclave there, or are you going to have two autoclaves there? Again, what is the severity or concerns about the agent that in the event that one autoclave is not operational, do you have a backup situation? Again, this is all part of the risk assessment process, and then how are you going to subsequently manage that risk? The pass-through dunk tank is that if you want to take a specimen at that biosafety level, that risk group organism, and transfer it to another facility for further work, this is an opportune way of doing it through a pass tank or some other mechanism, how to get it safely out of the laboratory so that the outside container is not potentially contaminated. Then the exit door, is that an emergency exit or is that an actual exit? So these are all things you have to think about. And again, I impress upon you to consider the first question you must ask is, what are the risks not only to me, myself, my fellow workers, and the outside community? Thank you, Ryan.
Oh, good point. Good point. All right, if we don't have any questions yet, if they do come in, think about it later. Even as a thought question, I think it's good to look at something like this and map out what an ideal facility is for your particular operations and think about what are some practical operational changes that you can make within those constraints. One of the efforts we're engaged in right now on a consulting effort is really working within the constraints of an existing facility where we can't change some decisions that were made, 10, 12 years ago even, from a design and a construction standpoint. How do we marry that with the fact that perhaps even the program has changed a little bit? Are the animal species going to be the same that maybe they envisioned a decade past? How laboratory equipment has changed, whether it's research or diagnostics. Still trying to make those things all work. So again, I think that, you know, even when you've got an existing facility, there's always an opportunity to look for improvements with respect to both risk and threat mitigation. If you have questions or comments after the fact, please continue to send those. Otherwise, Lauren, let's go to the next slide. So we're going to a poll question that actually will work. And this particular poll question is, which of the following access controls is not appropriate for the laboratory that you just saw? Whether they are badge entry, animal holding areas accessible to visitor spaces, or cameras at point of entry. Everybody has that burned into their brain. I'm going to open the poll. Poll is open. Leave it open for about another 15 seconds. We have 45% of who have voted. We'll go ahead and close and share the results of this. I'm not sure we could have asked an easier question, but animal holding areas accessible to visitor spaces. 100% came back with that. Absolutely agree. Although sometimes they are cute and cuddly, it's certainly not good from a safety or security perspective. Too close to where the visitors are. Conversely, I will say that there's nothing in the layout that we showed you where either swipe cards, your ID cards getting you in and out, or cameras would be inappropriate. All right. Next slide, Lauren. I'm gonna figure out where the slides went. All right. I'm waiting for you. Did I close the poll? Oh, it's another poll. Sorry, my bad. So and correct me if I'm wrong. I'm not seeing the slides at the moment for some reason, but I believe the next question is, which of the following engineering nope. What is the next poll question, Lauren? My slides have disappeared.
The poll question is, which of the following engineering controls is required for ABSL-3 but not ABSL-2 laboratories?
Thank you.
And the options are a separate controlled entry into the animal holding facility, self-closing lockable doors, and directional airflow.
The poll is open. All right, we've got about 43%. I'll leave it open another few seconds.
Yeah, I'm anxious to see the answers here because I'm in a learning mode.
Yeah, we'll have to talk about this one based on the polls coming in. I'm going to go ahead and close and share the results. So Bob, we've got almost 50% say directional airflow, 42% separate controlled entry, and a minority responding with self-closing lockable doors. Let's digest that one for a minute. Bob, talk a little bit about the directional airflow requirement, ABSL-3.
Directional airflow is a recommendation from the BMBL for ABSL-3 laboratories. With the construction of new laboratories now, the thought is the recommendation is to seriously consider directional airflow for a level 2 laboratory. So directional airflow is one of the correct answers for this particular question. I would also entertain controlled access to the laboratory, whether it be level 3 or level 2. Ultimately, what I want to do is protect the animals, not necessarily from people per se in toto, but some of the agents that these people may potentially give to the animals. Self-closing doors should be considered in level 3 laboratories. I don't know about whether or not the individual animal rooms should be locked, but the actual access to the laboratory should be so restricted that people who do not work in that facility should not be able to have access. And of course, the animal doors must be self-closing.
Yep.
Any more comments on that?
No, I think that's good. I think the standard answer based on the references where we've gone back and done all the research for this one in terms of what's required for ABSL-3 but not BSL-3-2 is directional airflow. But I think it's important to think about all these things. I'm going to go ahead and hide this particular poll, and we are going to the next slide. Let's see here. So really, we're talking about now the processes and procedures that affect biosecurity differently in an animal laboratory. So cost and maintenance and sustainability. One of the things that I think we tend to think about when we're building our physical security features in laboratories is often not just the access control and how they work together. It's amazing how many times people will go through that scenario of doors opening and closing, how that works. But now you've got animals in there as well. So what is the access control to the animals, which, depending on where they are in your priority scheme, now become assets, or depending on whether they've been inoculated, even agents at that point, or carriers. So of course, the size of the animals have an impact on that. Exposures, we know that from a biosafety perspective, when we introduce animals into a laboratory environment, we've got a whole new spectrum of exposures to agents. The one that always comes to mind is the Nipah virus, and being proliferated through pigs, and how that really can be a problem. There are a lot of examples, but bottom line is animals, they breathe, they spit, they poop. So there's a lot more opportunity for exposure. Really segues well into the waste management. Different spectrum of cost and sustainability there, as well as specimen processing. So what specimen are you going to be processing? And depending on the lab you're in, are you going to be getting a nice fixed slide, or is somebody going to be dropping off a dead raccoon at your doorstep? So those things obviously have a different spectrum on the risk side of things, but think about it from the threat standpoint. If you're dealing with something now that is infectious, the form and the format that it's in is there, as well as what is your process for getting it in. You think about the procedures of specimen in processing versus out processing. Who has access to that chain of custody? So depending on, like I said, depending on the nature of this, is this an animal coming in, or is this a test tube? Has a very different impact on how you look at that. Next slide. Speaking of specimen in processing, here we see a derivative of the hypothetical floor plan we were looking at. And you can see that we've got through the laboratory entry, whether there's samples that are going into the in processing, through the research, through storage, but we also have to think about the animal housing perspective and how that is going to move from samples collected from the animals into specimen storage as well. Bob, what else do you have to add on this slide, sir?
Just whether or not what type of specimen is it? Is a strictly diagnostic sample, or is it a sample that requires chain of custody? Suppose we're doing some forensic analyses or working with a law enforcement facility. So we have to think about chain of custody. And this, again, is just an example of how the process could flow. But again, it's all predicated on risk and what you're doing and where you're doing it and how you want to do it to maintain safety for everyone. So it's going to be different, but this is strictly a model. Thank you.
Got it. Next slide. Coming up on a discussion question. So again, for those of you that have, looks like, first of all, I want to make sure that the slides are back from everybody. Looks like they weren't showing up there momentarily. Looks like they're back up and running. Discussion question here. So for those of you that want to put something into the question box and talk about this, if you think about from the laboratory layout we've looked at, if this were the workflow of the laboratory described in the previous research scenario, what concerns would you have, if any? And I'll let that simmer for a moment. Well, we'll think about that. Bob, as you look at this statement, the workflow that we described in the previous research scenario, in fact, let's go back and look at that layout, Lauren. And, would you have any significant concerns looking at this layout from safety or security perspective with kind of the research scenario we talked about earlier?
Well, from the safety standpoint, with the potential contamination of samples going from the research laboratory into the specimen storage area and then going back into the research laboratory. So there are concerns to consider there about maintaining the integrity of the sample, especially from the sample going from the in-processing portion to the research laboratory with the potential for cross-contamination from previous samples. So that all has to be an integral part of discussions when you're talking about the risks that you may encounter doing something in this facility.
Yep, and actually a question came in asking about, how about transportation of specimens within the lab, and what's within that. So I think you tackled that pretty well and in the right timing as well. Great. All right, let's move past the discussion prompt to the next slide. So we talked a little bit about, from a biosecurity perspective and a biosafety perspective, differences in workflows and procedures and processes. When you put the animals into this environment now, what are we talking about that affects the biosecurity perspective? So we talked about animal movement a little bit, but I want to touch on that again. As we've said, most animals to some degree, and depending on the type of enclosure that they're in and the species that they are, they're mobile, they can move. And I think this provides both an opportunity for threat and vulnerability. Threat from the standpoint that they can be mobile carriers. From a vulnerability standpoint, now it really requires a tightly woven program to keep track of every animal all the time. From an equipment perspective, you're bringing different equipment in, and we talked a little bit about the fact that the laboratory itself, as well as equipment, can serve a purpose as containment from a biosafety perspective, but also the biosecurity perspective. So when we think about the different types of equipment that may come into a laboratory as a result of animals, we have different caging systems, we have different cage washing systems. There's a lot of benchtop equipment often involved in handling small animals, manipulations, sample collection. It is quite honestly a different type of laboratory. The personnel workflow changes. So a lot of times the workflow of an animal laboratory forces us to veer from maybe what we would like to have in a non-animal laboratory to account for some animals, particularly if they're large. We have to work around them at this point. And they're not always going to listen to us in terms of where we want them to be at any given time. So the ability to maintain your risk mitigation procedures and processes while at the same time you're doing your best to manipulate or sometimes even walk a large animal down a hallway. That's going to alter your workflows, and I think that takes a lot of thought. From a biosafety perspective, yeah, we're always trying to minimize exposures in those scenarios. From a biosecurity perspective, I can tell you from experience that when we bring animals into the laboratory, in terms of how we would like to have an ideal laboratory flow that gives us good visibility, simple access control, we look to minimize things. Animals will complicate that threat assessment process. And of course, access to supplies, specimens, research, and working stocks. The location of these things matter, and I think that it matters whether you're in a BSL-2 lab or a BSL-3 laboratory, whether this is proximity so that you've got optimized operations, but at the same time, when you're working with animals, sometimes the proximity of what you're working with is very important and the access to those things. So all of these things, I think, affect process flows. Let's go to the next slide. And a poll question again. So this poll question is, which of the following procedural controls is appropriate for the laboratory that we've been looking at? I am going to launch the poll. Poll is up. You've got animals. All right, we got about 43% voting. We can open it in a few seconds. And I should also indicate for those of you that may have forgotten, this is the BSL-3 onavirus laboratory we talked about in the earlier scenario. That changes your approach. I'm going to go ahead and close and share the results. The vast majority of you indicated that really all of the above is where it's important. And when we think about the viral research scenario we presented earlier, that makes a lot of sense. All right. Going to hide the poll. We're closing out that section. If there are any additional questions, please submit those. We'll be happy to answer those in real time or after the webinar. Seeing no questions coming in, I think we're prepared to move to the next slide. And Lauren, I think it's back to you.
Thanks, Ryan. So I'm just going to talk a little bit about personnel and training. And I would say that of the conversations that I've had with folks, either at workshops or at meetings, this comes up more than most topics of discussion. It is not uncommon for somebody to come up who's a biosafety officer at their facility and come up during the break and say, why can I not get my veterinarians to wear gloves while they're handling X? Or why can I not convince somebody to go with my appropriate biosafety protocols while they're handling animals. So when we talk about personnel security, I think of it in 3 areas: screening prior to hiring a person, management of your current personnel, and procedural guidelines, especially as related to outside behaviors. So when we talk about pre-hire screening, we're talking about security. So this might be a security clearance. It may be some sort of other investigation for personnel. Then what experience do they have, and what effect is that going to have on their ability to perform safely and securely in this facility? So in some ways, it might be that a person who has a lot of experience handling animals is going to be really well equipped to handle animals in a laboratory setting. Sometimes it goes the opposite way. Certainly, if after people feel a certain level of comfort with an animal, they tend to, at least on the outside of a laboratory, relax some of their safety and their attention to detail. So then individual qualities as well, and that's just personality. Do the personnel who are involved here, are they diligent? Are they able to follow procedures and protocols? And then animal interactions. So what kind of animal interactions have they had, and do they continue to have in their everyday life outside of their job? So for your current personnel, you have threat management and training. And so we talk a lot about insider threat from a threat-focused perspective, but we talk a lot less about that when we're thinking of biosafety and biosecurity. We tend to focus on the biologic rather than the personal components of threat management. And training is a little bit more difficult when you're talking about biosecurity. It's not quite as cut and dry as biosafety is in some instances. Then outside behaviors for the people who are working in the lab. One of the questions that we see a lot is, what about animal contacts outside of the lab? Is it appropriate for a person who has a lot of livestock at home to be intermingling with livestock in an animal facility? What about pet rodents versus rodents in the laboratory? What kind of handling restrictions do we need to put on laboratory personnel, and what kind of waiting periods are appropriate? So handling of personnel includes both the individual and the organization. It's important to select the right personnel. So honest and reliable workers are always going to be the foundation of a robust security program, and that's true for safety as well. And so screening workers as they come in is really important. Depending on the type of assets that you're working with, this might include a Department of Justice review process, so a clearance process. It might require a suitability assessment, depending on your individual protocol and the items that you're working with. Medical and physical requirements of the position are really important to consider here. So are the folks that you're bringing in, are they going to be able to be safe when they are working with the animals or working in whatever environment that you place them in? Fingerprints may be required as part of the clearance process, and complete clearances should be done before workers are given any kind of unescorted access to any part of the facility. So it's important to select the right personnel, but it's also equally important to maintain and promote a culture of safety and security. And I think this is probably one of the harder things to do, because it's difficult to prescribe culture and to weed out any behaviors that are not supporting that good culture. So technology is continuing to change, and a one and done training is not going to work. It's pretty easy to go in and do computer-based trainings for some of these things. And there's really, with time and with cost limitations and financial limitations for a facility, that might be what you end up doing. But often this should be really more of a discussion. So you need to ensure that the individuals that you're training are going to be able to take ownership. You can reinforce a desire to take ownership of behavior by providing science-based information, and I think that's really important. So because people are going to understand the need to protect themselves, protect other people, protect animals, either inside or outside the laboratory. So it should be part of a conversation. I know Bob last week was telling me a story about an audit that he did in a facility where he happened upon somebody who was in the process of not showering out. And I thought that was a really kind of a surprising thing to hear. But it's not an opportunity for punitive measures in that case. It's a sign of a change to the culture being necessary. So in that context, it's really important to be an ally with the folks who are working in the facility so that you can maintain that open dialogue, and people will be willing to listen and open to understanding the reasons behind the measures for safety and security that you have put in place. This should be a conversation. If you're having a conversation with the person who decided to skip on the shower out, there's evidence that this reduces the risk of people taking stuff home to their families. And so if you express that rationale and you provide actual evidence of the impact of people's behavior, they tend to be more willing to abide by appropriate behavioral restrictions and procedures. So training is really important in biosafety. It's also equally as important in biosecurity, but it can be a little bit more difficult. Often biosafety training focuses on really specific procedures and practices that take place on a regular basis that are consistently done. You know, you have a protocol when you go into a laboratory, you understand the safety requirements. The training for biosafety has also been ingrained throughout school and in other prior facilities. Everybody understands the need for it. Because some of the aspects of biosecurity are difficult to capture in that SOP format and really haven't either been instructed through school or consistently or constantly reinforced, it can be tough to teach. So this is where that dialogue and culture that we just discussed comes in. And understanding the principles of biosecurity will also allow staff to note anything out of the ordinary and bring it to those in a leadership position, so that if it doesn't fall into the category of normal operations, they're able to identify it as not right and bring that up to their leadership. So training to support biosecurity, it really should cover all of these areas: laboratory procedures, continuing to support that culture and climate of safety and security. And I think it's fine to talk about that. I think you should talk about how your culture is good and advantageous so that people take ownership and take pride in their work. Emergency response, accident, illness, and incident reporting procedures. What happens when something goes wrong, and how does that affect your security protocols? How are security personnel involved in the response? What happens during the loss, theft, or release of agents, or loss or compromise of keys or passwords? Because a lot of times we think about material security, but we don't think about data security, which is a huge part of all of this. And we won't get into it deeply today, but just to be aware of the importance of data security is really key. And then consequence management: what happens when something does go wrong? What happens if it's a big thing? What happens if it was an intentional event? And who do we need to get involved here? And then maintaining security of materials on a daily basis. You know, it's one thing to borrow stuff. It's another thing to just have stuff disappear. So while that might be just the tendency of the lab, it makes much more sense to have very good control of your materials and understand where everything is. So who should play a role? Yes.
Yeah, we've got a question came in that I think perhaps you and Bob can help address. And the question that came in was more back on the security clearances. And the question is, when is it considered adequate to require a security clearance certificate or a DOJ review process? You know, what situations make that a requirement versus a recommendation?
So for me, the easy answer is, of course, when you're working with a select agent, there are very prescribed guidelines for that kind of working with that kind of agent. So there are very specific laid out requirements, and that part's easy, which is really nice. I think for most positions now, even not working in a laboratory, anything where you could potentially be dealing with any kind of secure information or secure material, at least a background check is required. And that's pretty standard procedure. A lot of places will require a background check as well as a drug test, even for a non-laboratory role. And I think there is the thing to kind of balance is the expense of that kind of investigation with the value of it. And to note that it is, every time you do that background investigation or whenever you do, whether it's a clearance process or whether it's just a simple suitability assessment, it's still a snapshot in time. So you're looking at history up until now. You're not looking at future behavior. So while I think they're really important and they're certainly absolutely required in certain scenarios, you can't rely on only a background check or only a security clearance to protect you going forward in a security posture. Bob, what do you think?
No, I agree with you 100%. I have nothing further to add.
Great,
And
thank you.
I'd be really interested to hear what folks are seeing at their own facilities. So please write that into the text box and let us know. So then, Ryan, we have another poll question. Let's see how this goes. So the question is, prior to the initiation of this research, which of the following should have been involved in study planning? So our options are IACUC, security personnel, human resources, and all of the above. So we're talking about study planning here.
All right, I'll leave it open another few seconds. All right, I'm going to close and share. So here the majority, 3/4 of those that voted essentially said all of the above, that from a study planning perspective, should have been all the above, IACUC, security personnel, and human resources. Personal opinion, isn't necessarily the correct opinion, is I think the IACUC is definitely the place where that starts. We want to see the institutional committees like the IACUC and the IBC being involved in those processes. I think part of what goes into this is, as you look at a particular study and what are the potential impacts to either your risk or your threat management program, does that need to expand into other pools or cohorts of expertise like security and human resources? So I don't disagree with the all of the above. I think that perhaps there's a pyramid approach to this, but I'll let you guys comment on that as well.
So I'm in agreement with you, Ryan. I do think that it's certainly, if you have the opportunity to include security personnel or human resources in any kind of conversation about biosecurity and biosafety, I think you should definitely take that opportunity. If you're talking about what is the baseline of what needs to be done, really the IACUC personnel are the ones who need to be involved in the study planning. When you're talking about security personnel and personnel procedures, at an organizational or a facility level, it's absolutely your security personnel, it's absolutely your human resources. I don't think it hurts to involve everyone, but I think the minimum requirement in this case, I would say, is IACUC. Bob, what do you think?
Nope, I agree. I can't add anything more. Hopefully human resources have done their homework, and they should not be involved at that level, but I think the way you and Ryan answered the question was correct.
Great. All right, from a time check, we're down to about the last 5 minutes. Lauren, back to you.
All right. So I'll just leave this up here. If you have any questions, please let us know. Go ahead and feel free to talk into the text box, and then I'll pass it back over to Ryan to talk a little bit about integration and implementation.
So we'll Well, I can at least talk quickly, I think. So we want to respect your all's time and appreciate you all being here. So from an integration and implementation standpoint, we talked a lot about the bits and pieces. The other thing that I want to mention is everything we've talked about here today is really introductory, right? We could take a lot of these topics, whether it's lab design, threat management, how to do a threat assessment with animals, as the meat, no pun intended, of the content there. But, we can break those down, and we're happy to do that in subsequent webinars. What we want to do is give you the flavor of really what are the questions and considerations of how animals can challenge a laboratory biosecurity program. And that's really getting to think about their attributes. One thing that I wanted to mention is, in a traditional security setting, a lot of times it becomes very important for us to understand the attributes of the assets we're trying to protect. You think about whether you're, a true security guy, protecting a VIP or a presidential candidate, you really have to learn a lot about that person, that asset of how you're going to protect. What are their behaviors? What are their mannerisms? How does that impact how you're going to design a security program? We want you guys to go into the same mentality as you start to incorporate animals into your biosecurity program. What are the behaviors, attributes, and mannerisms of those animals that are potentially going to challenge that program? Once we've gone through that and we try to bring it all together, let's spend a minute here and talk about integration and implementation. Next slide, please. So we always, we showed this in the last webinar. I think that obviously very high level, but what we want folks to realize is that when we talk about biosafety and biosecurity, coalescing into this concept of biorisk management, that's really, one cog of a bigger machine that all factors into laboratory management systems. So alignment and congruency with other lab management systems becomes very important. Animals will challenge these things as well too. So your occupational health program, your regulatory compliance, emergency response, these things are all challenged because of bringing animals into the laboratory. We've spent most of the time today talking about biorisk management. Next slide. What's next? How do you implement? How do you do this? You've got to be able to identify your risks and threats. We talked about, from an agent perspective as biosafety professionals, we're all pretty seasoned at looking at the risks and mitigating those. The threat landscape is a little bit different. Not all of us are threat management professionals, and that's okay. It certainly behooves us to learn a little bit about what threat management is and how to do that threat assessment, kind of like what we talked about in our first webinar. The threat landscape obviously is always evolving as well. So identifying the needs for the risk and threat mitigation. How do you know if you need to do it? How do you prioritize? So really the execution of that threat mitigation platform, I think, becomes very important, and sometimes requires outside help with folks that have done a lot of threat mitigation and management. Implementation of the mitigation strategies. A lot of this is, not all of this is going to fall to your internal processes and procedures, whether that's training and drills, taking a good hard look at what's already on paper in terms of your security plans and programs and biosafety manuals, and of course a perpetual need to review and revise as programs change and as the threat landscape changes. Next slide. So this is a very simplistic formula. I like to show this because I think it helps people think about how these things come together. So what I've put here is that a threat plus a vulnerability, so you've got a potential threat moving toward an asset, and that asset has a potential vulnerability. The result of that is a potential risk or a consequence. And although this can be challenged and it's overly simplistic, I would argue that if you remove a threat or you remove a vulnerability, you've also removed the likelihood of a risk. And I'm sure everybody can think of scenarios where that would not be the case, but I think this is a good mentality to use when you approach those things. Next slide. Pretty basic. If you're looking forward for accountability and integration, we've got some tools that are up. Obviously, the WHO Laboratory Biosafety Manual remains a staple. BIMBL, currently at its 5th edition. Here we are headed for the 6th edition. I believe we're going to see some augmentation in the biosecurity category. Of course, that also includes some animal things as well. Plenty of other resources out there. And of course, we're all staying tuned for the Laboratory Biorisk Management System standard coming out of ISO as a result of the SIM workshop agreement. But I think accountability, the point here is that you've got to hold yourself to something. You've got to hold your program to something. and make sure that what you're holding yourself to is capable of withstanding the inclusion of animals into your program. Next slide. Steps, how do you implement? What's the recipe for implementing? Take a look at what you already got. What are the gaps? Revise, create, write new ones. Maybe there's some different reporting forms, different training materials. I always like looking at emergency response and incident management training and how those differ between labs with animals and labs without animals. It can be a little bit tricky. Next slide. Threat management, we always put this statement up, always includes response and recovery, because it doesn't matter how well you plan, we know stuff is going to happen. So make sure that as you're building your programs, that you're including adequate room to discuss these things. Next. Strategies, I think, understand your barriers and constraints. We talk a lot about that. That means know your institution. What's their tolerance levels for continuous improvement or augmentation of your programs? We talk a lot about cross-pollinating your committees. I think that's one of the easiest, cost-effective things you can do when your security folks are on your IBC, your biosafety folks are on your security committee. I realize that's not always practical, and every institution is different, have different cultures, but it's a good step to take. Next slide. So the other thing that I'll say before we get to the thank you slide, just to wrap up, back to that last slide, the other thing I would add to that is you got to be honest. You got to be able to take an honest look at your program and figure out really where those gaps are. And you have to be honest about what's going to be your ability, whether personally or as a group or institutionally, how you're going to look to solve some of those things. That can be a real challenging thing, and a lot of times as consultants, we get brought in to help facilitate those discussions. Sometimes people that are too close to the program have a hard time identifying what the gaps are, understand the need for those types of audits. But I think just being honest about your program is a big first step. So with that, I know we are right at or slightly over our time. If you have questions after the fact, please email us, let us know. I know that we want to thank both Dave Bressler and Joe Kozlopak for their contributions to the material here. A big shout out to Dr. Bob Hawley for agreeing to participate with us today. We're thrilled he was able to be with us. And then the other thing I'll mention just as a personal shout out, here in the past 2 weeks, we lost one of the good ones. Dr. Jonathan Richmond passed away. For those of you that may have remembered Jonathan all the way back at the days at Plum Island as, I believe, the island's first biosafety officer, and upward through to the point that he was running the Office of Health and Safety at CDC, obviously contributed to the U.S. and around the world with biosafety programs. That's somebody I think we're all going to miss. Obviously thankful for his contributions. So just wanted to give a brief shout out to one of my first mentors in the field, and hope all is well. Anyway, thank you guys. We'll be back in touch with announcements on the next installment of the series. And again, thanks to everybody who participated today. Signing off.